Hi, welcome to the last Open Security Summit session in January 2024. And we have Cenk and Matt actually talking about, what has to be one of the more puzzling titles we got here because eBPF is all about really low-level stuff. So I'm really curious to see, how this guy's going with the securing CI runners through eBPF agent, right? Which, it's all about understanding what's happening on CI pipelines, especially detecting malicious activity. So, guys, over to you.
Yep, thank you. So, hi everyone. We will be talking about first CI/CD runners, and then we will talk about So we will first talk about the problem and the solution afterwards. To briefly introduce ourselves, I'm Mert. I'm currently Principal Product Security Engineer at Yahoo, and my friend Cenk is the co-founder of ASPM Product Conductor and also the CEO. And as I said, first we will talk about the why of why we are doing it, and then how we come up with a solution, and then we're going to introduce the brief showcase of the tooling that we're also open sourcing now. So if we look at the thread landscape and just briefly giving some data, like if you look at the last year, according to the Sonatype report, there has been a multitude of attacks happened on the supply chain if you combine the earlier years. So if you look at the amount of attacks that happened last year, it's evident that attackers are more and more focusing on the supply chain type of thing because whatever you have in terms of security control, they can somewhat bypass them through the pipeline if they can compromise any package that you're using. And similar to that, if you look at the future as well, this is from Cybersecurity Ventures report. If you look at the future, they're expecting the damage that will happen due to the supply chain attacks, like nearly 120 billion. So it's evident that we need to do something about supply chain attacks. And in the current landscape, when we look at the common attack vectors, we mainly see three types of attacker interests. Like one is the vulnerable packages. They're finding a vulnerability on the package, and they're exploiting that uh, in the application. So this obviously brings some other hot topics in the industry, like the transitive dependencies and uh, or package scanning, like generating gas bombs, scanning them, etc. And the other attacker focus is like compromising the pipeline tools. Like they can compromise maybe GitLab runners that you're using, or maybe misconfigured environments that you're using to run these pipeline tooling or CI/CD tooling. And the other is the artifact or whatever, wherever you're storing your code or dependencies. They're trying to compromise the integrity of that so that they can publish their own malicious packages or malicious code pieces. And if you look at the recent examples and how they're achieving that, so one of the most prevalent things is, for example, repo jacking. If you check the Vulncheck blog that has been recently published, you can see there are multiple repo jacking opportunities due to the GitHub username changes. So basically, whenever you publish a repository that has been used by developers in Go package, and if you happen to change your package name, but the developers aren't updating them, you can easily publish a new module, rogue module actually, in proxy Golang org, which would cascade into the package Go dev. So that, for example, with a little bit of research, for example, in the Vulncheck blog, they discovered more than 9,000 repositories that are vulnerable to repo jacking, which can be easily used to replace whatever developers are using with the rogue package that you get to control. Uh, Similarly, Lazarus, North Korean threat group, recently published Ledger Connect Kit version that is used to hijack crypto wallets. So they achieved this through compromising a ex-employee to get a GitHub token from that employee to publish this malicious version. And although it remained alive for 5 hours, as you can see, it costed $600 in terms of monetary damage, just because people were in that time frame, people were updating their versions. And similarly, by the looks of it, like APT groups like Lazarus, they are they're using these techniques more and more by going after developers. One other example is like similar to Ledger. They also open sourced a package. Uh, this package was like they were having fake HR profiles, and in the GitHub they were having these repositories under the name of interview. And in these packages, they were poisoned with their payloads, and they were trying to fish developers under the pretense of making an interview, so that by the time that you download these packages to your computer and try to install the environment, they would infect you, basically. And similarly to this, they were doing this exact same thing with some popular crypto packages on the NPM registry as well. So if you look at if you look at what they do, they're highly trying to compromise either the package registry integrities by leveraging some of the popular applications, or try to hack the popular applications, or they're trying to upload legitimate rock packages under a legitimate pretense so that they can fish people to install them. And they are oftentimes using the second stage payload with these packages. And in NPM's case, it is usually in the pre-install pretense. And this is how usually the attack flow works. Like, user downloads the package. And in this case, since they're trying to compromise the developers or the users itself, at least this attack mainly targets Windows. But once you download the NPM package through the pre-install, they are checking if it is running in Windows. And if it is, they're connecting to their command and control server and getting the PowerShell script to do further compromisation and whatever they would like to do, maybe installing the implant or exfiltrating some data. So this is an example of one of their payloads, for example. In the pre-install, you can see they're trying to execute the index.js and then deleting that file so that you wouldn't see it, or you wouldn't find it. And in the JS itself, you can see first they're checking the environment, and then they're pulling the second stage payload to further compromise the phished user or the user that installed this package. So as we can see, there are multiple threat actors, and oftentimes APT groups like Lazarus targeting users and targeting supply chains by using these packages or package repositories. And if you look at the other examples like this, in the one instance published by Reversing Labs, we can see some malware are using GitHub gists or GitHub commit messages to communicate with their command and control centers. And in the one very good research that is published by Adnan, you can see they discovered the poison pipeline execution attack, where they can install their self-hosted runners in the non-ephemeral GitHub runners to do basically, for example, if you can look at the screenshot, they can enumerate the runner, which means that they can exfiltrate your keys, your data over there, since they're also persistent on the runner itself. So it is evident that whatever you do, for example, in your pipeline, at least during our threat research and analysis, it is our assumption that whatever you do, you need to exfiltrate this data to somewhere, which means that you're going to use some kind of network connection in the end. So when we look at the trend landscape, we realized this, and that's when we started to develop our own solution. Firstly, to monitor the network attacks, but we are aiming to extend the functionalities, which Cenk is going to talk about it in the upcoming section.
Yeah, thank you, Mert. So as you explained, the first line of defense for such an exfiltration malwares or attacks is ability to filter outbound network. So in the second of this presentation, I will explain you what we have done using the eBPF technology. And even though it's not an eBPF or how to develop an eBPF program, we would like to share all the learnings, some problems, challenges that we have seen, and we would like to share all of you. And we also share our open source program with the demo and everything, and we will expect everyone to contribute if needed. So eBPF is one of the hot topic in the cybersecurity world. This is pretty important because it gives you pretty low-level control in the Linux kernel itself. And one of the advantages of this technology is that it is safe, efficient, and it lets you control some kernel hooks at some point in a sandbox environment. And while developing an eBPF program, you're using C technology, but it's a kind of a simple C or minified C. So it is not a full-fledged C or C++ program. So it's a limited version. However, you can create your own sandbox environment modules and do some stuff in order to prevent it. So here I would like to talk about or share in the details what an eBPF program looks like, and what do we mean by hooking some syscalls, and how to interact with those kernel level actions with an application that runs in the user space. So as you can see here, by the way, you can find those examples in this link below. These are pretty simple examples. So one of the first things is that all eBPF programs should have two stages. One, C code or low-level code that runs in the kernel stage, and user space actions that lets you do your own stuff if needed. So in the second item, you will see a map. Maps are way to communicate, or maps are the communication channels between user space and kernel space, or maybe between two different kernel hooks. So in this simple example, we are using a perf event array type of map. And this is how we catch the kprop, CSA calls, and send into the user space. Kprop means that kernel prop. In this presentation, we will hear the kernel prop a lot. And CSA exec means that actually the shell exec operations that kernel catches. And obviously this is a pretty easy example, but if we go to the next slide. Right now we have a more advanced, slightly more complicated example. So in this example, what we are using is that the advantage of the eBPF technology, since it's a community-driven, there are lots of high-level SDKs or bindings that you can interact with your programming languages. For example, our code has been developed in Golang. However, right now the Rust, Go, and also Python are the popular programming language options. And this examples are using Cilium's eBPF bindings, eBPF SDKs to interact with the user space. So it is again simple. In the first stages, we tell that which function we want to hook. Then we bind the objects, because whenever we run this Cilium's eBPF to Go command, the compiled C code also transformed into the Go bindings, and this is how we can literally communicate or control everything in the user space. And finally, we actually catch the events that has been identified in the C program in our previous example, and we can print those events on the user space. So please check out those examples. So how we can use this technology in order to mitigate the problems that Mert explained. So what we came up with is that in all of the cases, there should be an outbound network connection. Even though eBPF lets you communicate or lets you hook other low-level kernel functions, for this example, we want to use the egress traffic, outbound traffic control options. However, we are planning to add more filters, more functions, or more mitigations, and we want to keep this project open source, and we want everyone to contribute it. What we can do is that we can actually query the DNS queries. We can have control over the file system. Maybe we can limit writing or reading in the certain files or certain important resources. We can list the process. We can check if which process are spawned. For example, if an npm install command spawns an shell code or some exa binary, executable binary, we can assume that this is a fish operation, etc. So the options are endless here. But our approach is that whenever an event occurs, we want to capture which process ID are getting outbound, and based on the logic that we have written in the user space, we want to tell the kernel to block or filter those options. However, how to start or how to identify or where to start finding those syscalls? Even if you don't know, or even if you're not familiar with the Linux source code, the easiest way to do that, running the strace command. Strace means that system trace. It is pretty popular command, and you can easily install on any Linux machine. And so, as you can see here, when we run a curl command, we can have some functions written here. So if you want to capture or filter outbound traffic connection, we can use those operations. The first operation is the TCP connect call, and the second best option could be the socket operations. One thing that you should know about kernel programming or the low-level programming is that the execution order is pretty important. So based on the operation that you want to have or you want to provide, some things may work or may not work because of the execution order. However, here in this approach, we are going to first identify which process IDs, PID, process ID, process name, is going to communicate or sends TCP connect request to which outbound resources. Can we go to the next one? Yeah, so as I explained to you, the ability to modify data in the kernel level programming is not available for each syscall, because when you're interacting with the kernel, it is kind of dangerous to play with the kernel environment. And the groundbreaking technology that eBPF provides is that you can do this without crashing the kernel. Before, I mean, if you would like to do something in the kernel, or if you want to load the kernel module, if there's a problem on your code, the system will basically crash and you need to rebuild it. However, eBPF uses a just-in-time compiler to double-check if your code is working properly. But as a trade-off, this eBPF technology, some props or some trace functions will just give you the observability monitor features. On the other hand, for more modify actions, you may need to use other system calls. For example, on our first example, the kprop and trace points are some syscalls or functions that just lets you read the data. So it's not going to let you allow the modifications. On the other hand, the XTP or more low-level function calls will let you do the modification. As I explained to you, the execution order is important in the eBPF technology. This means that as you move below, so as you move into the network layer or hardware layer, some high-level function may not work. For example, in the XTP case, XTP is actually working in the hook point of the network interface card. So it is a pretty low-level stuff. And since the traffic coming or traffic going from that network card is not yet assigned with a specific process or even socket, the visibility will be limited. On the other hand, as you move to the upper stages or the user space, user land, you will have more high-level functions. For example, for the XTP case or the C group function case, high-level function like function that lets you get the process ID or the task name, process name is not going to be available in the network layer or the XTP layer because the kernel has not assigned yet. So that's why the XTP could be great function. For example, if you would like to create an DDoS protection system or network layer routing function, etc. So what we will do is that we will use some more high level and more maybe slightly low level functions to achieve this. So what is our playbook? For our playbook, first we will capture the K-props, kernel props. We will send those props into our user space, and then using cgroup egress function, we will try to block or filter the traffic that is allowed or not allowed from our user space. Obviously, there could be some challenges because again, because of the execution order or because of the technology that you try to build, you may have some limitations. But our functions like that. So in the right side, our eBPF agents will create a few maps, and those maps will be used by different kernel hooks, and it is going to be bidirectional. So some hooks that kernel identifies sends a message to our user space, or some input that we receive from our user space or eBPF agent will be sent to the kernel space via maps to do the magic. Can we go to the next one, Mert? Yeah. So what we are trying to achieve is that we are built an eBPF agent, and this agent will work on your pipeline. And based on the allowed host list that you provide, we will just give you the access or let you do connect, or we'll block the network traffic to prevent those kind of outbound malware actions. So this is an example that shows how this technology works. And here we have the Mert, maybe you can increase the length, increase the size, yeah, full screen. Okay, so this is the dry run of the code. On the left side, we are running our eBPF agent as a single binary. So this is a single binary. The advantage of using the single binary is that you can run this in the Docker world or basically any Linux machine that the eBPF hooks are available. You can also limit these options as well. So what we do is that we just tell our eBPF agent to use the allowed host. The allowed host in this case is the download.conductor.io. First, we try to go to the google.com. It's not working. Then we are testing the amazon.com. It's not working, but since the download.io, download.conductor.io is one of the allowed hosts, it is working. And after we killing the service, we will have a report table available, shows you that those CloudFront domains are pass policy, because this is basically the download.conduct.io domain names, but the other addresses are basically has been blocked in the network layer. So that was the this simplest dry run feature. Right now, we will use this same technology, same actions in the CI/CD runner, and we will try to explain what we have done and how we can improve this actually. So first, we have a binary setup function. Obviously, we can develop an fancier GitHub app, but since it's an open source project right now, we are using this simple binary. The second, the next action is that the malware action. In this example, we are using a webhook site to understand if the network is reached to the outbound or outside of the CI/CD stage. This is the webhook binary, and this is the secret or simulates the malware action, because on our research, we have seen that one of the common attack vector is leaking the secrets, GitHub secrets, or some GitHub-related environment variables into the outside world to do more. So this hopefully will prevent the first item in the attacking space. The second action is the alloft action. Again, we are using just downloading some artifact from our accepted host or alloft host. And finally, we will print the report, and we are expected to see which policies have been applied and which outbound connections has been blocked or not. So let's run the action and let's see what happens. So the advantage of this technology is that it's just not going to work in GitHub, right? This approach could be available or can be the same for Jira runners, for GitLab, or basically any CI/CD runner that you have. So as you can see here, the binary run in the previous stage, and as the next stage in the prevent action, the network basically timeout, so it's not reachable. The alloft action worked perfectly, so the artifacts has been downloaded, or whatever the action that we want to do is been already done. And down below we have the report written somewhere in the host system. So even if the control binary has been killed, the reports will be available. We have developed, or we have used this approach because let's say your runner or conductor binary or control binary is running in the Docker environment. You may not be sure when this Docker runner is going to die. So in this case, we want to keep the events updated at any time. And in order to be parsable or usable from other resources, we are using the JSON formatted reports. And finally, the execution will pass. So this is going to be a successful run or some successful action. However, the malicious outbound connections will be dropped or will be stopped by the control binary. So let's wait a couple more minutes to understand. Yes, here you can see that the webhook URL, it is the same URL. However, it did not receive any message. By the way, you can test this code and this approach on your environment. And if you find any errors or any improvement points, just let us know. We are right now waiting for the GitHub runner to be finalized, and in a couple of seconds, we will see that the action has been finished successfully. Yeah, so this is the report. This is the blocked policy, and underneath we have the pass policy. The first block policy As you can see in the domain name, it tries to reach the webhook site. So it is something that we don't want to have. The second is the address that or artifacts. So it is something that's okay for us. So the purpose of this research was we knew that we know right now that the supply chain attack vector will increase, and we know that such a security solution may not be enough for some cases, but it is obvious that almost all of the CI/CD or supply chain securities are staged or using multiple stages. And using such a monitor or observability feature, or maybe the preventing vulnerabilities, we can understand what's going on, even prevent what's malicious intent. And this is how we believe that the supply chain attacks will do less damage. So this is the open source code that we developed. We are planning to create a framework or supply chain security framework using this technology. So we are planning to add some plugins that maybe checks the outbound address from a threat intelligence platform, or maybe we can have deep dive process level analytics to let the system to decide if there is a malicious thing going on or not. So eBPF is a groundbreaking technology, and it's getting more popular in the cybersecurity world. And we wanted to develop this project to show how eBPF technology can be useful in different areas to protect our code from malicious intent.
Yeah, we can take questions if you have any.
Yeah, I had a couple. So I was thinking, how, when you guys have this running, right? Can you detect that it's there?
I mean, right now, the binary takes some inputs, allow host inputs from the user. So the allowed or outbound addresses should be predefined or should be given into the binary. But there are obviously other ways to do that. So what we want to do is that, first we want to have a monitor function, and we want this project or the binary to self-learn which repositories are using which addresses usually, and maybe automatically detect anomalies in the network traffic if there is any. So this is the vision that we have, but right now you should.
So I was actually coming back from the attacker point of view. Can the attacker know that you're there?
The attacker? No. I mean, based on the capabilities of the attackers, obviously, but this service runs in the kernel level. So let's say you have a self-hosted runner, and on the self-hosted runner, if you position our binary as a daemon or background job, then it will be very hard for an attacker to know that there is an eBPF.
Well, that was my question. My question is, it should not be detectable, right?
Yes. You can always hide the process and everything. So this is slightly different topic, but yeah, there are ways to do. There are ways to hide the remainings of this project, of this process.
Yeah, cool. Now, and look, I also think that one of the great values of this is to really, even if you're not being attacked, is to pick up all those signals, like you show the secrets, the bad stuff you should be doing, network access, downloading stuff we're not supposed to download. I work on a couple of projects where we had to build air-gapped environments, and even for build, and it's amazingly hard, right? It's very easy to download half the internet, right? When you do a build. Right. So I think this kind of stuff allows you to get a lot more visibility into what's going on there, right?
For example, the benefit of using this technology instead of firewalls is on the runtime, we can decide if this IP address is safe or not. So this eBPF technology have this capability. But obviously, if you running your CI/CD runners on an air gap network or on your self-hosted runners, then and you have the doors, right? You can just shut down the doors, disable the network access, and it's okay. However, we are planning to improve this tool more to self-sufficient in a way that, or self-learned in a way that finds the vulnerability or anomaly and detects it and prevents it.
Yeah, basically the aim is to make this agent self-conscious so that if any attacker tries to enumerate on the machine that something works to detect the signals, this would know and at least signal the user that, hey, this is something going on and you need to check this pipeline run.
So one of the things that is coming, right? And I think, if you guys start thinking like that, you would also make an interesting evolution. Is I feel that these kind of tools, you do fall for diminishing returns in terms of complexity, because there's a moment where you start to get so much data, right? So much information. I feel that, there's a massive space here for LLMs, to have an LLM, especially now that we're getting into smaller, self-contained, even shippable LLMs are run in one environment, to allow you to almost start to understand context, right? Because one of the things I would love to have and these also even during development, right? Because I always find that tools like this, if you cannot add value in normal development time, they lose a bit of stickiness, right? Where if you can get people to use it, forget about security. Sure, we got so much value from this technology, right? That you want to use it. And where you sit, you in a way you see reality, right? Which is really cool. Like you actually see really what's happening, right? If you could start to translate that more into almost the intent and what's going on at the more abstraction layer, like this is what the application is doing. And what's interesting about that is that if you think about it, you should see the evolution of the app, right? You should see the app doesn't start by having lots of functionality, it starts small. And almost is interesting as even for the technical managers, right, to start understand when they make change the attack surface, right? Let's say that we do a threat model on an app. You guys can also add some triggers to say, oh, by the way, the attack surface of the app just changed, right? Or the build of the app just changed. Suddenly, you went from an app that had this amount of dependencies to that amount of dependencies, right? Or you have an app that had this amount of attack surface to that amount of attack surface, right?
Yes.
And I think that's really interesting to visualize that, right? And to put that into context.
Yeah, exactly. It lets you to, eBPF is actually phenomenal technology for observability.
Yeah.
Because you literally have all the options running in this Unix machine, Unix host, and you don't need to do anything basically. So you can just see everything. And obviously what we see is that our vision is to do more on the process side, like which process spawning, what kind of processes, and maybe holding a list and comparing this list with the previous run.
Exactly.
This could be an easiest way to find anomalies in the space.
But think about using the LLM and the prompt as code. Right. So the interesting thing of what you just described is that, and this is what I feel the big evolution in the next, one of the evolution in Gen AI is that it allows us to build intelligence in some apps like the one I described, but where the logic is not just in the code, is in the prompt. And that means that as you tweak it, you just modify the prompt, or you modify the prompt for certain things. And then that's going to be always easier to do than having to modify the prompt. Right. Where almost like the core technology just has to provide the observability and the object models, right? And then you allow the prompt and whatever system you put in there to map that, to visualize it, and to because like you said, if you can start to map the processes and the span and the thing, you get some really nice graphs, and then you analyze the graphs on top of it, and you can say, okay, 90% is normal. We see that all the time, but well, this 10% here is really weird. and then you can focus on that.
Yeah. I mean, I think there are lots of potential here, and we would like to discover those capabilities with the help of community, obviously. So that's why we want to share this project as an open source project. We also had ability to test some maybe prior to tools or some other technologies in the market that tries to aim this approach. But we see that we developed slightly more elegant solution. And
I
we
think
would like to
observability is
develop
massive,
this.
man. I'm not sure if you covered it. Did you talk about the implications of all these S-bombs and bill of materials and stuff like that?
This will come. Yeah, we are heavily investing in this technology, and we know that we actually have research how to generate dynamical S-bombs dynamically in the build time.
Because you fucking see it, right? That's the thing.
Yeah, you basically see all the files have been downloaded or copied or reached or touched or created and everything.
Look, here's something I always wanted to do, right? I always wanted to have a release, even at OS level or container level, that only had the files required to run.
Yes, this is slightly difficult because
not really. If I can run all my unit tests, right, and all my integration tests, and I can basically tell you, no, but that's you always have to do that, right? So if I could say, I ran my entire unit test suite, I ran my entire integration test suite, and I just need that functionality.
Yes,
we should be able to get rid of 80% to 90% of what the hell's in there, right? Even in Python distributions, right? Even in node distributions, like why do you need 50,000 packages, right?
I mean, high-level new programming language like Rust or Go kind of support this, so you cannot import a library that you are not consuming in the application logic, but this is not the same thing. So I'm just using one function.
Even the libraries, man, they're fucking massive, right? Like, think about it,
like 99% of the library is not getting used, so you just need one function.
But I think you guys, think about some of those use cases, because there's a couple sweet use cases that if you can hit one of those, sometimes it feels weird because you build all this stuff and it's the use case that it's almost a side effect. But those use cases only exist because of the platform you built, right? So you kind of need to also have a couple of those use cases that become almost like the killer app, right? For that. And applying an LLM on top of this would also allow, in a way, you to jump a generation, right? Because I think the problem with the previous, people who try to pull this off is that when you hit the moment of diminishing returns, you have to code yourself out of it, and it's too complex, right? Where if you were to apply an LLM and prompts, then it's just about how good the data is, how good and how well formatted, massaged, all that stuff is. So,
yeah, you're right. And I mean, long story short, we will see lots of eBPF technology in the cyberspace. And it is exciting.
No, this is really, really cool. Look, we do another session in every 3 months. So in April, if you're moving at this speed, come back and do an update, man, because I do think it's one of those where we need to get a lot more of the community behind it, right? Because I'm a big fan of eBPF, right? I always wanted to use it more than I have. So I'm glad you guys are making it, because last time I looked at it, I was like, whoa, this is not for the faint of heart, man. It's like
and one of the things that we are discussing with Mert is that we also want to share what we have learned, because it's a kind of it is great community, but it's not easy to do some magic in the kernel space or low level stuff. We will share everything.
But my advice to you is share the journey, right? And even if sometimes it feels like it's you talking to Mert publicly and Mert talking to you, like especially LinkedIn is really good now, in other places, in your blog, on your site, and your GitHub. Sometimes it does feel that you're speaking to the fog. But don't worry, it goes through, right? It's like it's a long game, right? So I find that in this case, like sharing the journey, sharing the challenges, sharing what you publish, it's always good, because you're always going to be better, right? So it doesn't matter how rough it is today, you're solving a really hard problem, right? So keep sharing, keep collaborating, even to yourself sometimes have threads in public. Might feel a bit weird, but every time you do that, there's another person who read about it. There's somebody who goes, you make that little connection, my connection, and then you have that long threads of materials.
Exactly. Yeah, we'll do that.
Brilliant, man. Well, thanks for doing this session. I love when we get these nice, deep technical sessions, man. It's always cool to do this stuff. Thanks, you guys, and I see you in the next one.
Thank you.